My name is ultracapacitor, CEO of NAWA Technologies. It's located here in the south of France, in the region known as Provence. Not only a beautiful place to arrive to work in the morning, but also working on some exciting technology that's changing the future of energy storage.
NAWA Technologies is developing a brand new material for storing electricity. With this material, we are able to manufacture some innovative supercapacitors and also electrodes for the next generation of lithium batteries. If we take the analogy of athletics, for instance, an ultracapacitor would be a sprinter. It will be recharged very fast and can be discharged very fast. A lithium battery is much more like a marathon runner. So what we are doing at NAWA is something that is exactly in between.
With our technology, we can have 5 times more power and 5 times more energy than the existing technologies out there. We can charge and discharge our technology in a matter of seconds, and we can do 1 million cycles. So you have something that can last a long time and can charge and discharge very fast.
The basis of this technology starts with the material. The material is made of vertically aligned carbon nanotube. Unlike any other technology, which is basically based on powders, our material is like a kind of cage which is made of trillions of all vertically aligned carbon nanotube. A nanotube is a tiny tube of carbon with a very small diameter. Typically, in our case, it's 5 nanometers and a very long length, 100 micron. So it's a little bit like playing with a spaghetti that has 1 kilometer long. So you can have a trillion of this nanotube in a square centimeter. We have developed a very specific and patented method to produce our electrode based on vertically aligned carbon nanotubes. All this advantage allow us to demonstrate and develop a very specific coating process to grow vertically aligned carbon nanotube on the 2 sides of an aluminum or a copper foil.
What we use is abundantly available and it's natural. We're not using any materials that you can say are negative environmental aspect, like cobalt that you have in lithium-ion batteries, or materials that you can consider to be rare earth materials, so they're not abundantly available. This technology can go very, very many places. Power tools, automated guided vehicles, which is what you have in logistics and material handling in warehouses, to automotive applications. All those devices need some power burst and the ability to recoup energy. Another advantage of the ultra-fast carbon battery is that it's very durable. So you could see that this technology could be used in space, in the oceans, perhaps in drilling applications as well, and will not be affected by the temperature and the extreme environments that it's exposed to. Another market that's really taking off at the moment is what they call the Internet of Things. This is, of course, many different applications, but the area that we see a lot of opportunities anywhere there's any communication, especially within tracking and security applications. We are investing in the production equipment to have a production line operational by 2020 and delivering off of that line hundreds of thousands of cells.
We have a project to develop what we call a structural battery with the idea to integrate a storage function into a composite material. The battery is directly into the structure, into the shell of your car, into the shell of your iPhone, or into the shell of the wing of a plane.